The title of the talk is Innovative Scientific Computing by Integration of Simulation plus Data plus Learning, S plus D plus L. This is the history of our systems. Recently, we have more systems with accelerators, such as GPU, and this continues in the future. Supercomputing is changing now. We have new types of workloads related to big data analytics, AI, and machine learning, in addition to CSE for simulations. Integration and convergence of simulation, data, and learning, S plus D plus L, is important towards Society 5.0, super smart and human-centered society by integration of cyberspace and physical space. Since 2015, we have been developing a new platform for integration of S plus D plus L, which is called BDEC, Big Data and Extreme Computing. We are focusing on S. Our approach is based on AI for HPC, AI for science, digital twin. Wisteria BDEC01 is the first BDEC system, which is a platform for integration of S plus D plus L. Peak performance is 33.1 petaflops and aggregated memory bandwidth is 8.38 petabytes per second. The system is constructed by Fujitsu. Operation started on May 14, 2021, and it is hierarchical, hybrid, and heterogeneous system with two types of nodes. Simulation nodes for HPC, Odyssey, with more than 25 petaflops is based on Fujitsu's Prime HPC FX1000 with A64FX with high bandwidth memory. This part has the same architecture as that of the Fugaku supercomputer. Data and learning nodes, Aquarius, a GPU cluster consisting of Intel Ice Lake and NVIDIA A100 Tensor Core with 7.2 petaflops for data analytics, AI, and machine learning workloads. Some of data and learning nodes are connected to external resources directly. This is the ranking at ISC 2022, June 2022. Odyssey is 20th of the top 500 list. This is how we utilize the Wisteria BDEC system for integration of simulation, data, and learning. Models and parameters for simulations are optimized by data analytics and machine learning. H3 Open BDEC is an innovative software platform for integration of S plus D plus L on the BDEC system. It is a 5-year project supported by Japanese government since 2019. PI is Kengo Nakajima, and total budget is $1.41 million for 5 years. Collaborators are specialists of computer science, high-performance computing, computational science, numerical algorithms, data science, and machine learning from various institutes in Japan. We have 3 significant innovations in H3 Open BDEC. One is innovative method for numerical analysis with high performance, high reliability, and energy saving, which is based on the new principles of computing by adaptive precision, accuracy verification, and automatic tuning. Another innovation is integration of simulation plus data plus learning by hierarchical data-driven approach. We also have the third pillar of the project, software and utilities for heterogeneous environment, such as Wisteria BDEC01. Actually, Wisteria BDEC01 is the first really heterogeneous system in the world. Here, I will talk about the coupler. Generally, multi-physics coupler, such as PP Open Math MP, is doing weak coupling of multiple applications. But our new coupler, H3 Open Util MP, has more sophisticated capabilities. We are developing a new coupler which combines Odyssey for simulations and Aquarius for AI machine learning. Because the Wisteria BDEC01 is heterogeneous, a single MPI job over Odyssey Aquarius is impossible. Actually, they are connected through InfiniBand EDR with 2 terabytes per second. We are developing a communication procedure with H3 Open SysWait IO socket, library for inter-process communication with MPI-like interface. H3 Open SysWait IO socket enables direct communication between Odyssey and Aquarius through InfiniBand EDR. This is the API for the communication library Wait IO socket. Its interface is very similar to that of MPI. Wait.io socket was open for public this June. We are also developing a Wait.io through file systems. This slide overviews 3D earthquake simulation with real-time data observation and assimilation on Wisteria BDEC01 using H3 Open BDEC. We utilize real-time data from more than 1,000 observation points through SciNet. This is a system on Wisteria BDEC01 using Wait.io library. Aquarius is doing filtering and visualization, while Odyssey is doing simulation and assimilation. This slide shows code written by Fortran calling Wait.io library. Aquarius is sending the result of filtering, and Odyssey receives the data. In the next part, I will introduce our ongoing work for coupling of science simulations on Odyssey and AI workloads on Aquarius using our coupler and Wait.io library. This slide shows an example for atmosphere simulations of clouds by my colleagues. This simulation includes two parts. One is a high-resolution model for detailed simulations. Another is coarser model for parameterization. This time, we replace this coarse model for parameterization with AI. This part requires 25% of the total computation time. The target in this study is microphysical processes of cloud. The data-driven cloud model predicts atmospheric state changes per time. In this machine learning process, air density, internal energy, and density of water vapor are the input, and their gradient in time direction is the output. PyTorch is used for a framework for machine learning on Aquarius, and multi-layer perceptron with 3 layers was applied. Left-hand side is the input, middle is the output by simulations, and the right-hand side is the output by inference. Generally, simulations and AI agree well, but reproducibility of extreme values needs improvement. Next, I will talk about our future perspectives. We are shifting to GPUs in next 10 years. This is essential for maximum performance under constraint of power and energy consumption. We are introducing OFP2 system under collaboration with the University of Tsukuba in April 2024. We expect more than 200 petaflops peak performance. It consists of GPU cluster and CPU only part. Before that, we are introducing a small cluster, Wisteria Mercury. OFP2 and Wisteria Mercury are equipped with same GPUs. Porting cores of more than 3,000 users of the previous system, OFP, with Intel Xeon Phi to GPU is the most critical issue. We just started to do this. Finally, I talk a little bit about the successor of Wisteria BDEC01. BDEC02 will start in 5 or 6 years from now. We keep the direction of Wisteria BDEC01 towards integration of S plus D plus L. This will be a GPU-focused system with a combination of GPU cluster and CPU cluster. Moreover, we are thinking about introducing DPU, IPU, quantum-inspired devices, and multiple types of GPUs for supporting workloads for data and learning. Programming environment and communication library for integration of HPC and such devices are needed, where we can extend the idea of Wait.io. Thank you very much for your attention.